All right, so we had success with integrating 1 over x squared from 1 to infinity. So maybe we can also do 1 over x. It looks a lot like, on the right-hand side anyway, it looks a lot like 1 over x squared. It just doesn't go to 0 quite as fast because it's only 1 over x, not 1 over x squared. But let's see what happens. Can we do it? So let's do the integral from 1 to t of 1 over x dx. Okay? And we know that the integral of 1 over x is the natural log. Natural log of x. Absolute value of x, right? Evaluated from 1 to t. Okay, now we don't really need the absolute value because we're looking at we're looking at a positive interval, so that's not a big deal. But so what do we do what do we get when we evaluate that at 1 and t? So we get the natural log of t. Now I'm going to just leave off the absolute value signs because I know that t has got to be greater than 1 because it's my upper bound of this of the interval. And so and then I get minus the natural log of 1. And the natural log of 1 is just 0, so I get the natural log of t. All right, so now we've evaluated the definite integral. Now let's look at the limit as t goes to infinity of the natural log of t. So what happens? Well, we know that natural log of t goes to infinity, right? All right, well, so, all right, we don't get a nice finite value in this case. So what we say is that this diverges. Okay? So we don't get a finite value, and we say it diverges. Now, if we get a finite value, we say it converges. Okay, so I kind of skipped over this when I showed you this in the definition before. So they're convergent if the limit exists, and they're divergent if the limit does not exist. So in this case, this diverges. All right, so I'll meet you in the next video.